Sir, over to you.
Yeah.
Just a minute, Divya.
Yes, sir.
Yeah. Have you made some announcement for YouTube viewers? Okay. I have
Okay. Yes.
an announcement. Just yeah. I think the participants, you must have received one email about SAQ, as ma'am was just talking about SAQ, second SAQ. Second thing, you are supposed to give the feedback of your participation, your experience of this program. So that again, in your classroom that is available, so you'll be expected to give your detailed feedback. Okay. And also there is a valedictory function tomorrow at 5 p.m. So these announcements you must have received. So it is essentially, I'm just repeating certain things to the YouTube viewers. First of all, we are very happy for your participation on the YouTube live streaming of this program. One or two things I would like to share. Those who are viewing the YouTube live streaming and you are communicating with the mentors, okay, we are very happy for doing that. So what we would like your feedback, your experience in the YouTube live streaming. Please express yourself, and if you have some comments for any improvement, that also you can do. Kindly express yourself about the program, your learning through this program on YouTube. So everything, whatever you feel like, so please express in the comment box in the YouTube. And finally, as just now I mentioned, tomorrow we are going to, so this is going to be the last session for OFCM 2022. So last session for this YouTube live streaming as well. So tomorrow evening, afternoon at 5 p.m. we will be having our valedictory function. So it will be for around 1 hour or so. So those viewers in YouTube live streaming, if you are willing or if you would like to, so you can join the valedictory function which will be held tomorrow evening, tomorrow afternoon on Zoom meeting like other sessions. So if you would like to join the valedictory function, and even you can express yourself also in the valedictory function. So if you'd like to join, please write an email with your identity, your ID of your YouTube ID to the Srini.
Yeah.
Can you write down on the screen the
Yes.
email address?
Yes.
Email address is foundations dot mtts at gmail.com. So this is the email ID for this program. So those who would like to join the valedictory function, please write an email to this email ID. So we'll be sending you the invitation. Yeah, thank you once again for joining us. Thank you.
Yeah. Thank you, Professor Baba.
Thank you, sir.
So, with those nice words, let's start the session. Yeah. So let's revise again. So when do I say a function f from x to y is 1, 1? Okay. So one of you should be ready. So 1, 1, 1 to 1, injective, all are same name. Okay. When do I say a function is 1 to 1? Quick. Yeah, why it's taking time? Yeah. So let's start from R1. R1 Thangapandi, quick.
For all a comma b belongs to S,
Ah,
such that f of a not equal to f of b.
but what is your yes?
S equal to
Yeah.
a comma b belongs to x cross x, such that a not equal to b.
Right, fine, fantastic. So, yeah, for all AB, okay, in X with A not equal to B, what should happen? F of A not equal to F of B. Okay, this is one definition, right? So, the contrapositive statement we said, right? Abhinaya, are you ready with that? Quick, R3 Abhinaya.
Yes, sir. If f of a is equal to f of b, then a is equal to b.
Right. If f of A equal to f of B, then A equal to B. Right. Okay. Fine. Right. Good. So same thing. Either one can use this is definition one, or you can use the same contrapositive statement. Okay, given AB with the f of A equal to f of B, then what should happen? A equal to B. Again, same thing for all AB in X. If I have f of A equal to f of given AB, right? Better I'll write. Given AB in X with f of A equal to f of B, then what should happen? A equal to B. Okay, right. I hope all of you have understood this, right? Okay, I'm clearing all feedback. Okay, let's now check with some examples. Before that, let's do on to also and come back to examples, right? See, f from x to y is surjective. The name that's injective. This is surjective. People call it as on to, right? So when do I say a function is surjective? Let's look at the picture. Let's assume this is x and this is y. Okay. So when do I say a function is surjective? What is the idea? So every element in the codomain, okay, given y in y, I should be able to find a pre-image. Okay. This x should get mapped to, okay, that y, this y is equal to f of x. Okay, right. So think about this. Now you have to yeah, you have to express it symbolically. Yeah, be ready. For each element in the codomain, I should be able to find an element in the domain such that the image is this, right? Okay. Yes. Now we have to fill in this. Okay. Yeah, quick, no? See, this is the 12th session. See, things should come fast. Okay. If you have some other element, is that there should be some A. right? Such that z equal to f of a. So here for each of them, I should find some fellow. Okay, can't you make it symbolically? So same questions, same set of questions. Is there a quantifier? Which quantifier? What is its underlying set? And what is the property? That's what I have to think. Okay. But why only 12? Okay. R9 Gubendran.
Sir, for every y belongs to y,
Very
such
good.
that f of x equal to y, sir.
No. You have to be very careful. Because I don't know what is f of x. So you got to say that carefully. How many quantifiers are there? You are right. Okay. That means actually what should happen? You should find
An element x, sir.
you should find, no? So which quantifier should come? There is
So
at
there
least
exists-
one. There exists should come. There exists. Very
Some
good.
x in x.
Right. With what property? You said that already.
Y is equal to f of x, sir.
Very good. Okay. So all of you look at this. If you have understood, say yes. Check whether he has said correctly. For each element in the codomain. Okay. For every y in y, I will be able to find an element in the domain. There is at least one element. Okay. It's enough if I give one element. Such that y equal to f of x. Okay. So far only 30. 30 of you have said yes. What is the, now it's nearing 60. Okay. So it should be at least 50, 40. Yeah. Okay. Right. So that's 1, 1. Okay, 1, 1 or injective, right? It's injective. I'll write here injective, bracket, I'll write 1. Okay. 1, 1 is this. Distinct elements have distinct images. Surjective means every element in the codomain has a pre-image. What is the pre-image? This is what we call pre-image. There is an x such that y equal to f of x. Okay. Right. But for every element y in the codomain, I can find at least one x such that y equal to f of x. That's all. Okay. Also, when do I say f is bijective? If it is both injective, f is bijective. If it is, okay, both injective and surjective. That if it is 1, 1 and on 2. Okay, right. So now let's work out something, right? Okay. So work out some examples. So let's take, okay, f from n to n. Okay. Let me start with the identity function. F of n equal to n. Okay. So the question is f 1, 1? If yes, say yes. If no, say no. Easy question. So 20 seconds time. Yeah. R8 Devashri, R9, I'm sorry. R8, no. Devashri is from R8. Yeah.
Yes,
R8 Devashri, yes.
yes, sir, it is 1, 1 function.
Why? How do you prove it?
Because for all a comma b with a is equal to b, f of a is equal to f of b.
That is not the definition of a 1, 1 function. See, you are changing. Look at the definition carefully. 1, 1. How should you start?
For all a comma
No, don't worry about A comma B. Start with f of A equal to f of B. What you should prove? A equal to B, right?
Equal to B.
Do
Yes,
not worry. See, for all I have to prove, I have to start with arbitrary AB. Do you understand this?
yes,
Yeah.
sir.
Yeah. So start with arbitrary AB or NM, whatever. Start with the NM. Okay. And I have to assume, what is that I have to assume now? F of N.
N is not equal to M.
Oh,
Or
you
N
want
is
to,
equal to M.
no.
Shall we use AB, sir?
Okay.
Okay, sir.
AB. Let's use AB in N. Okay. Given AB in N. Okay. What is that I have to start? See, one way I have to prove is if A not equal to B, I have to prove f of A not equal. Don't confuse these two. If A not equal to B, okay, so assume let A not equal to B. So I have to prove f of A not equal to f of B, right? So what is f of A?
F of A is A.
So f of A is A, and what is f of B? B.
F
Right?
of A is equal to A.
What is
F of B is equal to B.
So do I know f of A not equal to f of B?
F of B. No, sir.
See, I have assumed A not equal to B. Okay, you have already said f of A and f of B. From that,
Yes, sir,
whether it
not
follows.
F of A not equal to F of B.
Yeah, so A not equal to B,
Because
I
it is
know.
distinct terms.
That's right. A not equal to B is distinct, but f of A is what? A. So it's given. For me, the same thing, f of A not equal to f of B. Do you understand this? A not equal to B, I have to start
Yes.
and prove f of A not equal to f of B. But f of A is same as A. F of B is same as B. Already I know A not equal to B. Therefore, f of A not equal to f of B. Yes? Do you follow that?
Yes, sir.
Okay. Okay. Either you can do by this way. So f of A is A, f of B is B. Therefore, f of A not equal to f of B. This is one way of proving. The other way, do not confuse with this. I have to start with A not equal to B and prove f of A not equal to B. What is the other way of doing? I am clearing all the feedback. If I want to use second definition, how should I do it? Contrapositive definition. How should I do it? I have to start with which statement? Think, all of you think about it. 20 seconds. Quick. Respond quickly. Okay. Up to Jyotika.
Given A, B belongs to N, let A is equal to B.
That's not the thing, no. Let A equal to B. See, all of you do not know the definition properly. What is the contrapositive statement? Contrapositive statement is, see,
Let F
already
A
somebody
is
said,
equal
if f of A equal to, I even rub all this. If f of A equal to f of B, then A equal to
A
B.
is equal to B.
Here also rub all those things. Simple. If A not equal to B, okay, it's for each and every element, okay. If A not equal to B, then f of A not equal to f of B. Do you understand these two statements?
Yes, sir.
Okay. Now I am asking, see, already we have did this. We have started with A not equal to B and proved f of A not equal to f of B. Now I want you to do by this. Therefore, what is that you have to assume?
A is equal to B.
You have to assume A equal to. How do you start the proof?
F of A is, let F of A is equal to F of B.
And prove that A equal to B, not assume. Have you understood? Okay.
Yes, sir.
Let's start the proof. Let f of A equal to f of B. What is f of A?
A.
What is f of B?
B, sir.
Therefore, A equal to?
B, sir.
Whether all of you have understood this? Yeah, I'm clearing the feedback. Have you understood this? Let's do some more also. Good. Okay. Let's do one more example. Okay. Second definition also we got it. For that, I have to assume f of a equal to f of b and prove. Okay. In fact, that was the last class I gave R to R 3 into n. Okay. So let's do this. F from R to R. Okay. F of x equal to, say, 3x. This we did in the last class. Is it a 1-1 function? I'm clearing all your feedback. Quick. So you have to be ready with the proof, not with just yes or no. Okay. If you are through, say yes. If you are even know the reason and stuck up in the proof, say no. Yeah. R6 Sultana.
Sir,
Hmm.
sir, this is 1-1 function, sir.
Yeah. Your proof.
Sir, f of y equal to 3y.
No. You have to start with some assumption, no?
Yes, sir. Let f of x equal to f of y.
That's how you have to start. Very good. Therefore,
Therefore, f of x equal to 3x and f of y equal to 3y.
therefore,
So, therefore, f of x equal to f of y equal to 3x equal to 3y. Therefore, x equal to y.
right. See, you start like this. F of x equal to f of y. Therefore, 3x equal to 3y. Okay. Therefore,
Yes,
x equal to y. Right.
Yes, sir.
So actually it says 3 into x minus y not equal to 0. Therefore, x equal to y. Is that okay? Right. Now I'll ask a general question. So that let's check whether all of you have understood. Now I am rubbing this 3 and I'm putting alpha. Okay. And I'm saying f is 1, 1. Okay. Then what can you say about alpha? I'm clearing all your feedback. Yeah, let's. But see, the response is slow. I thought people will respond. I'm waiting for you. Okay, R9 Malati.
Sir, alpha should be any arbitrary constant.
Alpha should be alpha is a real number. Okay, that is there. Alpha should be a
Any constant, sir.
Yeah, that's what I have fixed alpha. Fixed alpha is fixed. Okay. So you have to, okay, right. You are not thought about it. Kalishri, R7 Kalishri.
Sir, I too thought alpha is any real number constant, sir.
No. For all real number, whether it will come? That's my question. Can I put 5x? Can I put 7x? Can I put root 2x? Is it true for every real number?
Yes, sir.
Oh, okay. then people say there is no condition on alpha. Is that correct? There is no condition on alpha. How many of you say, if it is correct, say yes. If it is wrong, say no. Okay. All right, Matish, quick.
Sir, real numbers except 0.
So there is a condition. Okay, that's the condition I'm asking. It says alpha should be not equal to 0. Okay. Very good. I'll ask someone else. Kaushik? R7 Kaushik?
Yes, sir.
What happens if alpha equal to 0?
F of x will be equal to 0.
And therefore it becomes a?
Not a one function.
Not a one function. Why?
Because there is no element
No. You should not say like
mapping.
that. If I want to say something is not 1, what is that I have to find? Go by definition and answer. If something is not 1, what do I mean by that? Either use any one of them. I had to find.
Sir, if f of a is equal to f of
A equal to b, but f of a not equal to b, and f of a equal to f of
f of a is equal to f of b.
Right? So find. So can you find two numbers like that? F of x equal to 0 for this case. If alpha equal to 0. See, this is true for every x. No, give me two numbers. What is f of 1?
F of 1 equal to 0.
Give me
and
one
then f
more.
of 3 is equal to 0.
Yes. But 1 not equal to 2, right? So it's not a 1 function. If alpha equal to 0, it is not a 1 function. So f of x equal to alpha x. So I'm writing it here. F of x equal to alpha x is 1. Alpha fixed already. Don't say alpha is a constant. Alpha fixed. Fix alpha. Okay, now it's already fixed. Of x equal to alpha x is 1. If and only if alpha not equal to 0. Okay, already you have proved if alpha equal to 0, f is not 1 because it's a constant function. Okay, now let's prove this way around. F of x equal to alpha x. If I have to prove this way around, right? I have to prove this. If alpha not equal to 0, then f is 1. All of you think about this way. Quick. Already we have done this. So you got to just think. And all of you should give the reason where you are using the fact alpha not equal to 0. Only two. See, try to prove now alpha not equal to 0 is given. I want to prove f is 1. How do I start the proof? All of you know already. Assume f of a equal to f of b and prove a equal to b. That's what you have to do. Please be quick. All of you be quick. Very, I don't know what's happening. What's happening? Yeah. All right, Krishnamurthy.
Yes, sir.
Give the proof.
Sir,
how do I start the proof? Say
f of a equal
f of a equal to f of b. Let's start with this. Okay. Then therefore what happens? What is f of a?
F of A equal to alpha A
Very good.
and F of B equal to alpha B.
Very good. F of A equal to alpha A and F of B equal to alpha B. Therefore, what happens if I put it in this? Therefore, alpha A
Equal to alpha B.
Then that's where
Then alpha will cancel.
why I have to do this, right? Best way, don't say cancel. Best thing is I'll bring this side, alpha A minus alpha B equal to 0. That says alpha into A minus B equal to 0. Okay, when is the product of two real numbers 0? If one of them is 0, either one of them. When xy is 0, xy equal to 0, if x equal to 0 or y equal to 0. Yes, but now we want to prove A equal to B. We want to prove this to be 0. Okay, right? So this says either alpha equal to 0 or A minus B equal to 0. But already I know alpha is non-zero. Therefore, A minus B equal to 0. Since alpha is non-zero, A minus B has to be 0. Therefore, A equal to B. So here is the place where I'm crucially using alpha not equal to 0. The point here, right? I'm allowed to, yeah. So I'm clearing all the feedback. Can all of you go through this proof? And if you have understood, say yes. I want to really see how many of you are participating. Very good. Okay. See, you have to write it at your time. Okay. Now let's ask a question. Suppose if I have F from R to R, okay. Okay, let's ask about this. Let's go to this. F of x equal to x square. Is F one? I'm clearing all your feedback. No, now don't answer. Let me clear the feedback. Now answer. If it is 1, say yes. If it is no, say no. Very good. Those who are saying no should be ready with, okay, the proof. For each one of them, I want proof. If it is not 1, I should be ready with the proof. If it is 1 also, I should be ready with the proof. Okay, very good. So far, no yes answer. Everyone of you are feeling 18. I mean, got only 18 responses. Okay. Look at, all of you should look at the, understand the definition carefully. See, when I want to say something is 1, I have to prove for every A, B in X with A not equal to B, F of A equal to F of. If I want to say something is not 1, it is enough for me to produce. Okay, what is the negation? There exists A, B. That means I have to produce only pair of points which are distinct. A not equal to B. Okay, for see 1 means for every A, B in X with A not equal to B, F of A not equal to F of B. Okay. Not 1 means this is 1 definition. Not 1 means there exists A, B in X. with A not equal to B, such that f of A equal to f of. So it's enough to find 2 points. Okay, very good. Let me check whether you are ready. Okay, R8, Haripriya. Haripriya? Yeah. So you are saying no, right? F of x equal to x square is not 1, 1. So you give a proof for that. So for that, what you should do? You should find 2 points, right? Have you understood what you should do?
Yes, sir.
Then tell. Give me those points, quick.
F of 1 equal to 1.
Very good.
F of 2 equal to 4.
That's okay. But they are not equal, no? That's not I want. Look at this carefully. I want f of A equal to f of B. If I want to say not 1, 1, I need points such that they are distinct, but images should be same. If you take 2, images are also different. Do you understand this?
Yes, sir.
So give me some other point. Think carefully. Square only, no? Which
F
square
of
is 1?
minus 1 equal to 1.
Very good. Very good. That's all. That's all. Okay. Now this 1 and minus 1 are 2 distinct points, but the images are same. That's enough to say that this is not 1, 1. Okay. Do all of you understand? I'm clearing the feedback. How many of you have understood? Very good. Okay. See, for the same function, let's try to change the domain. Okay, let's put f from positive itself. Okay, 0 infinity to r, f of x equal to same function x square. Now check whether this function is 1, 1. Is f 1, 1? I will clear the feedback. Now my function is new because I have changed the domain. Okay. Rule is same, but I have changed the domain. Okay, fine. Only 15 of you could figure out. See, now I can't work with the same idea, right? See, here now minus 1 is not allowed for me. See, here it's allowed because there it's a function from R to R. It's a function from R to R. Therefore, I can choose minus. Minus 1 is there in the domain. Now I can't give the same proof. I can't simply say f of 1 is 1 and f of minus 1 is 1 because minus 1 is not there in the domain. So it is not allowed. I can't do this. So it stops. But that's not the proof to say it's 1, 1. I have to prove it. Okay, it's 1, 1. Okay. Let's ask somebody from R1. R1. Jayashree. Jayashree.
Let A comma B belongs to 0 to
That's
infinity.
okay. You start with f of A equal to f of A. That
Sir?
will be fine. Right. Yeah. Start with f of A equal to f of B.
Yes,
Right. Of course, A comma B belongs to domain. Then only I can take f of A, f of B. Okay. Then what does it mean? Quick.
A square is equal to B square.
Fine. Yes. Next step. Obvious thing now, bringing this to this side. You are not thought about it. How many of you?
A square minus B square is equal to 0.
Right. A square minus B square equal to 0. Okay. Then next step.
Since A, B are positive.
Very good.
so
I will
A
factorize
plus
A
B
minus B into A plus B equal
must
to
be positive.
A minus B into A plus B should
0.
be equal to 0.
Yes.
Okay. Now I want to prove this to be 0. Therefore, I have to say this is non-zero. Okay. How do I know this is non-zero?
A and B are positive. So A
Very
plus
good.
B greater than 6.
Very good. Excellent. A and B are positive. Therefore, A plus B is also positive. Therefore, this is none. That forces A minus B equal to 0. Therefore, A equal to 0. Right? Okay. So, either breakout room, okay, breakout room exercise, discussion hour exercise. What is it? Do the same thing from close 0 command. Okay, 0 is also allowed. Yeah, little bit you have to change here because both, okay. You think carefully, okay? Good. That's fine. Let's think about this. Okay, f from R to R, f of x equal to x cubed. Okay, quick. So is it 1, 1? Most of you should know the graph, right? Yeah. Okay, that geometric thing will come back. But now you say whether it's 1, 1 or not. Maybe take it during discussion, however, and do it, right? Yeah. So E is 1, 1. This is also exercise. Is 1, 1. Okay, but you have to do it very carefully. I don't know how many of you are having argument. Let's see. Kalishwari, do you have a proof for this?
So let's take f of x is equal to f of y.
Yes, 1, 1. Yeah. Okay. F of x equal to f of y. Okay.
X cube is equal to y cube.
Okay.
X cube minus y cube is equal to 0.
Right. Now I have x minus y. I have to factorize.
Into x square plus xy plus y square is equal to 0.
Okay. So I have to say this is non-zero, right?
Yes, sir.
How do you say that? Now x and y are allowed actually. Okay.
Yes, sir.
Go back and think. This is the place where you have to think carefully. Okay.
Yes, sir.
Okay. See, here no problem, right? This is going to be greater than or equal to 0, right? This is going to be greater than or equal to 0. This is also going to be, see, first understand, if x or y equal to 0, okay, x cubed equal to y cubed, therefore other thing has to be 0. Have you understood this first? If x equal to 0 or y equal to 0, then x equal to y. Because I have x cubed equal to 0, that forces x equal to 0, right? Then x equal to y. If one of them is 0, then x equal to y already I have got. So assume both of them non-zero. Therefore, this is going to be positive. This is also going to be positive. Here is the place where I have to be careful. Okay. Argue with sign, no? When this will be positive? If both have same sign. Okay. Always both will have same sign because you have assumed x cubed equal to y cubed. If they have different sign, then this, okay, then x cubed cannot be equal to y cubed. Since x cubed equal to y cubed, x and y have same sign. Therefore, xy is positive. Therefore, everything is positive. Like same proof. X squared, y squared, xy, all of them are positive. Therefore, this is positive. Yeah, so I have roughly see the work is there. Go back during discussion hour and finish it. This is completely discussion hour. Okay, very good. I will stop here. Let's ask some other question. We have done already, right? So we have done. In fact, f from x to x, identity function. Okay, let's ask about identity function. So is it 1, 1? Quick. See, I want fast response. Is f 1, 1? Any set x. Okay, I have identity function. Is it 1, 1? Quick. Only this much. Again, we are doing the same thing. Assume f of x equal to f of y. Therefore, I am going to get x equal to y. Already, therefore, I have proved it, right? Therefore, f is 1, 1. Okay. Let's go for onto and do it. I want to ask whether this f, okay, this is identity. So, f is 1, 1. Okay. Now, my question is, yes. Is f onto? No. I'm clearing all your feedback. Okay. Yeah, quick. I'm waiting for your responses. 10 more seconds. If you go by definition, you'll be able to do. Go slow. That's fine. Yeah. But R5 is totally empty, is it? Lekashri, Safia, Darshana, Kavipriya, Irgadarshini, none of you have answered. Okay, Rahul. Rahul? Yes, answer quickly. Okay. Yeah, give the proof. Yeah. You say yes, right? Okay.
Yes, sir.
So
How
should I start? Yeah, it's on to. Yes. Okay. How do I start the proof?
For all y belongs to y.
Start with y in. Don't say for all. Okay. Start with y in x. Let y belong to x. Right? That's why we say given. Given y in x. What is that you have to find?
We have to prove that y is equal to f of x.
Right. Find x such that. Okay.
Yes, sir.
What x you will choose?
X belongs x in capital X.
That's what you have to, all those conditions are there, but still you have to see, you have to say choose x equal to something, and then x belongs to x, and you have to say y equal to f of x. Choose x belongs to something, then x in x, and y equal to f of x. These two things I have to prove.
X equal to f of x?
No. That's very easy, no? See, we want y equal to f of x, no? But what is f of x? You see, this is a particular function. What is f of x?
X.
So what is your x? I have to choose.
X is equal to y.
Choose x equal to y. Okay. Then y already you know it belongs to, yeah, it belongs to x. Correct? Everything is
Yes,
there. And y equal to f of x. The point clear? Okay.
yes, sir.
How many of you have understood this? I'm clearing all the feedback. I have to start with y and I have to find somebody. Okay, from the domain such that keep it z if you don't understand. F of z equal to y. Okay, that z has to be y. F of y equal to y. That's our definition. Okay, so I got to choose some z. That's what you got to do. So I'm choosing x equal to y. Then x in x and y equal to f of. Okay, let's do this function. Let's take f from R to R. Let's choose f of x equal to 3x. Is f on to? Quick, clearing the feedback. Is f on to? See, again, start with, see, all of you should think in this line. Okay. I don't know whether it's on to or not. Let's start. Okay. What all we want? Given y. Okay. In R, can I find x? Find x. Okay. Again, in R, with what condition? F of x equal to y. That's what I have to find. Okay. But I know what is f of x. What is f of x? I don't know. Let's find, assume something is there. Let's find. I know already what is f of x. F of x is what? 3x. 3x equal to y. Now what is that I have to find? Go back and ask. I have to find x. From 3x equal to y, can I say what x is? That's the thing. Okay. Now, is there any improvement? Have you got the answer? After my explanation, I'm completely clearing all the feedback. Okay. I'm trying to prove it onto. I have started with some y in R. I know that I have to find x in R with what condition? F of x equal to y. Okay. For a moment, I have to assume, okay, suppose there is some x that f of x equal to y. Let's find out that x. Okay. What we call it as, okay, solve. That's what we do, right? We have an equation, we solve. So working backwards. Assume some x is there. And find really what is condition on x. So f of x equal to y, that's what I want. So therefore, I have 3x equal to y. From this, can't I find what x is? Of course, x will be in terms of y only, correct? So can you say what x is? Quick. I want to really see how many of you do. I'll give 10 more seconds. Okay. Yeah, Akilandeshwari.
X equal to y by 3.
That's it. That's all. X equal to y by 3. So given y, I know there exists x such that f of x equal to y. Now I have to really verify. See, this I have worked backwards. Okay, and found out. Now let's see, start like this. The proof now, verification goes like this. Let y belong to R. Choose x equal to what? Y by 3. Now really I have to check whether f of x is y. Now I calculate what is f of x. F of x is what? F of x equal to f of y by 3. But I know what is any f of z. F of z is 3z. Therefore, it is 3 times y by 3. Therefore, it is y. So I have proved f of x equal to y. See, this is one way around, finding way around. And now I have verified that it works. Whatever I have done works. I'm clearing all the feedback. Okay. Let's give another function. G of x equal to 3x minus 1. G from R to R. Is G on to? Quick. Okay, let's go to R5. Let's go to Lekashri. Lekashri, quick.
Sir.
Yeah.
So first we have to choose the value of x. F of x.
Start. See, where should I start? Start with an element in the codomain, right? So keep the notation. See, we have already worked.
Let y belong to.
Right. Okay. Now you have to find, I don't know. Okay. Choose x such that g of x equal to y.
G of x is equal to y.
Right. Now you complete it. Quick.
Y is equal to 3x minus.
No, not y equal to x. I have to choose x. I have to find x only, not y. Y
X
is given to me. Y is given.
Y
I have to find x.
Yes, sir.
So how do you find x?
Y x is, sir, x is equal 3x minus 1 is equal to y.
Therefore,
X is equal to y plus 1 by 3.
That's all. Okay, I'll write it clearly. Y plus 1 divided by 3. That's your x. How many of you have understood this? Okay, quick. Is this G 1? I'm clearing all your feedback. Quick, do it in mind, and I want good responses. Yeah, R2 Anusia, quick.
Sir, yes, sir, this G is common, sir.
Prove it.
Let G of x is equal to G of y.
Very good. Then?
G of x is equal to 3x minus 1. And G of y is equal to 3y minus 1. Therefore, 3x minus 1 is equal to 3y minus 1. No, 3x minus 1, we have to.
Yeah, you can use cancellation, right? Therefore, 3x equal to 3y. 3x equal to 3y. Therefore,
Then x is equal to y.
3 into x minus y equal to 0, but 3 is non-zero. Therefore, x minus y equal to 0. That says x equal
0.
Okay, right. Okay, you can also use 3 for 3. Multiplicative inverse is 1 by 3. So I can multiply both sides by 1 by 3. 3 into x minus y equal to 0. 3 into 1 by 3 into x minus y equal to 0. That says x minus y equal to 0. Is that fine? That's the cancellation law you are using. Yeah?
Yes.
Okay, very good. So therefore, this G is a bijection. Okay, it's both 1, 1 and non-2. Therefore, G is a bijection. Okay.
Can you give for discussion f of x equal to ax plus b?
Yes, sir. Sure. F from R to R. Okay. So A and B in R. Okay. And the f of fix A, B in R. Okay. F of x equal to ax plus b. Okay.
Check when it is 1, 1 on 2.
Yes. Check.
Under what conditions A and B?
Right. Under what conditions on A and B? B, F is 1. Okay, same thing, F is also. Right. Yeah. Okay. Now let's.
Srinivasan, I'm just curious.
Yes, sir.
Can you ask how many of them can do it in mine? They had already done 3x minus 1.
Yes, yes.
Okay. Now, how many of them can do in mine and come up with condition?
Yes, yes.
I'm ready to give 30 seconds.
Yes. So all of you heard the question, right? How many of you can find, okay, condition on A and B so that it's 1, 1?
Those who can do, say yes by green signal.
Yes.
Quick. Yeah, 40 seconds are over.
Right.
Let's ask.
Let's ask someone. Okay.
They should feel happy, those who did it.
Yeah. Yeah, Kalishwari, Arsavan Kalishwari.
So for f is 1, 1. Let's take f of x is equal to f of y.
No,
no, just say it.
Just say the condition.
Conditions on A and B.
Right.
When it is 1, 1.
Sir, A should be greater than 0, sir.
Oh, if it is negative, it's not? Okay, so ask somebody else. Quick.
A should be not
No,
equal to
enough.
0.
Your time is up. Next.
Yeah. Let's ask Devashri. All right, Devashri.
Sir, A and B not equal to 0.
B should be non-zero?
Yes, sir.
Okay, next.
Okay. Let's go and ask, yeah. Abhinaya, R3 Abhinaya.
A is not equal to 0, sir.
That's the only condition.
Yes, sir.
Is it on to then? Yeah, it's 1, 1. Is it on, also
yes,
on
sir.
to?
Yes, sir, it is on to.
Very good. That's the correct answer.
Right.
Good.
Good. Yes.
I ask others to discuss it in the.
Yeah. See, this is for discussion hour. See, look at what condition she said. Okay. But anyway, you discuss it during discussion hour. I hope all of you would have heard, okay, what she said. There is a condition on A, not on B, right? Right. And of course, discuss it thoroughly, full, okay, with proofs. Okay. Right. Now let's go for this. Okay. Suppose if I have f from x to y, okay. So x is there here. Let's assume y is also like this. Okay. And I will take a subset A, subset of x. Okay. Now what I want to discuss is what is f of A. Okay. So let's do it in two forms. Okay. First, I'll do it in listing form. So what is f of A? Can all of you find out f of A? What kind of set it is? Is it a subset of x or is it a subset of y? I'm clearing all your feedback. So if at all I have to search and find f of A, where should I find? In x or in y? Which set should I find? F of A. Good. Or Ramya? Or someone Ramya? Huh?
Subset of x.
Subset of?
X.
X. Okay. Darshini?
Sorry, it's a subset of y. A is in x. F of
A is a subset of x. Therefore, images, right? Okay.
Yes.
It is something like, see, what is, see, suppose if I have a small x here, then f of x will fall inside y. Okay. So, I want to talk of image of a, this is image of an element. I want to talk something like image of a set. Therefore, what should I do? Okay, what should I do? Look at the elements in A, okay, x in A, right? And collect all such f of x, okay, all the images. Is that clear? See, z is in A, then I have to collect f of, see, f of z could be somewhere. See, this is f of x, f of z could be somewhere. That I have to collect. Okay, I have to do a collection here. Okay, somewhere. I don't know where it could be, but I have to collect wherever the, okay, images go. So in listing form, how it should come? I'm collecting all the images. Okay. Can one of you say how I should write in listing form? Quick. It's a quick question. How should I write? Start with whatever elements in A, collect all the images, right? X in A, then I have to collect all the images. Only one of you is ready. Okay, let me ask. Abhinaya, quick.
Z comma f of z.
No. Image. No, it is not ordered pair. Okay. So collect only the images. So I will collect only f of x. Where does it should belong to? X should belong to A. Okay. This is listing. Okay. Start with one x. Collect that f of x. Don't collect x. I don't want x. Start with the x in A. Collect f of x. Start with z in A and collect. Okay. Take another z in A. Collect f of x. Whatever elements in A, you have to collect those images. Have you understood? Have you understood the description? Okay. Whether all of you have understood? F of A listing form is simply f of x such that x belongs to A. Okay. Only this much people have understood. Come on, what is this? Okay, what is a image? This is called image of F under A. Image of F under A. Under the set A. A is a subset of the domain. This is a definition. F of A colon equal to means I have to collect, okay, all the image. I will take points from A. For each point of A, the image of that point I will collect, okay, and form a set. Collection of all image points where the points come from the set A. That's all. Okay. Now let's look with the property. Suppose I say Y belongs to F of A. By that, what do I mean? Look at the picture and understand. Okay. Assume this is F of A. Now I say Y belongs to F of A. From that, what can I say? Can you just say the property? Y is an element of F of A. Then what can you say immediately about Y? Oh, somebody's having doubt? Jayashree, yes? Jayashree?
Under F only, sir.
Yeah?
You have written image of F under the set.
Set A. Oh, yeah. Thank you.
Image of A under F.
Under the set A. Correct. You are right. Thank you, Jayashree. Under the set A. Yeah. So Y in F of A. From that, what can I say? Oh, only two of you are saying. See, Y is an element. That means what Y should be equal to? It should have got, see, I'm collecting only the images, no? So what all I know? I can say that I can find at least, see, in this, okay, assume this is A, then therefore what can I say? I can find at least one X such that this X should have mapped to Y. Is the point understood? Y is an element of F of A. Then Y is of the form F of X where X in A. See, already you know, right? This is the set. Y in F of X means what? Y equal to F of X for some X in A. Already you have listed, no? Listing form you said, right? Y equal to F of X for some X in A. Is this understood? I'm clearing the feedback. Good? Is it okay? Fine. Okay. Now, how should I write this statement? For some X in A. Some of you say it very precisely. Is there a quantifier? Which quantifier? Say it properly. We'll try. R1 Jayapriya, are you ready? Yeah. So I have to write it clearly with the symbolic form. Y in F of A, F. Yeah, please say. Okay. You are not ready.
So for
so which quantifier should come? For some X in A, which quantifier should come? Okay, now time is up. Let's ask Agatya Lakshmi. R for Agatya Lakshmi. Agatya Lakshmi, come quickly. Agatya Lakshmi.
Set of F of A such that A belongs to 1, sir.
That already we have said. For some X in A, can I see Y in F of A? Can I write a condition? Can I write it in symbolic form? Have you understood this? Y if it belongs to F of A? Let me write it clearly again. I'll go to fresh page. Okay, what is F of A? Already we have written in listing form. Okay, what is the understanding? I'm collecting all the images where the elements come from the set A. Okay, right. Now I'm asking if y belongs to f of a, can you say it properly? Can you give a condition? Okay. Quick. Or to Anusia? Anusia?
Sir,
Say quick.
sir, there exists
Good. There exists.
f of x. X belongs to A such that B is equal to f of x.
Y equal to f of x. Very good. That's what I'm asking. Okay. So therefore, what is the official description of this set? Collection of all elements y in y with this condition. There exists x in A with what condition? Y equal to f of x. I think you have to go back and discuss this. Okay. I don't know why. This we have done already. Quantifiers we have checked. We have written a lot of exercise. Okay. So f of A has two descriptions. This is listing. This is official. Okay. I think we are shooting time, right? Okay. Let's do one small example and stop. Okay. Let's take constant function. F of R from R. Let me define f of x equal to 3. Or fix some constant y naught. Okay. Let's fix y naught. Fix y naught in R. Okay. Now, can you find out what is f of R itself? How many of you can tell? Clear all feedback. Quick. Only 4 of you. I want, it's very easy question, therefore very easy answer. Krishnamurthy, all right, Krishnamurthy, quick.
Why not, sir?
No, but it is a set, no, don't say why not. Correct it and say. Krishnamurthy, correct it and say. Why not? See, this is a bus. Why not is a passenger. Bus is not equal to passenger. So, what should I do? This singleton, why not? That's how you should answer. Okay. Right. So, what is f of? Okay, set of positive real numbers. Let's write even something else. I'll simply say what is f of natural numbers? Quick. I'm clearing all the feedback. See, for each natural number, what should I do? I have to see what is f of 1, I have to collect. What is f of 2, I have to collect. What is f of 3, I have to collect. Use this definition, okay? Use listing form. You will be able to do it quickly. Okay, don't go by official form. This helps you very well to find out what it is. Quick. Yeah. So we are running short of time. One of you should say quickly. Let's ask someone. Lekashri. R5 Lekashri.
Sir, singleton, why not?
Again singleton, why not? So what better you can say? Given any subset A of R, what is f of A? Given A subset of R, f of A is?
Singleton, why not?
Right. Singleton, why not? Okay. See, if you have time, go back to discussion hour. Try to find images of your known functions, right? Something like f of x equal to x square, f of x equal to sin x. Take some sets and try to find out what is the images. Okay. Yeah. I think it's time I have to stop. So I'm stopping. Before I stop, let me give the textbooks, okay, or reference books, whatever you want to say, okay. So from MTTS team, we have a very good book on foundations, okay. You can go through. What is the title? The title is a foundation course in mathematics, okay. A foundation course in mathematics. Mathematics, okay. The author is, of course, Ajit Kumar. Professor Kumresan and Professor Baba. Okay. So, Baba Kumar Shah. Et al. In fact, I should write et al. And publication is Narosa. Okay. You can go through this book. You see, the thing is foundation you have to thoroughly. And also go to MTTS. All of you know MTTS website. Okay. Lot of expository articles are there. Expository articles. Okay. Catering to BSc students. In fact, lot of very good articles are there for BSc students. Okay. With exercises. Okay. A lot of set of exercise set is also available. One such is available for foundation also here. And the book is made out of that exercise set. Okay. So, in fact, you can find out. Okay, go to. I'm not giving the URL directly. Go to MTTS website. You can find out expository articles. There you can find out a lot of articles on foundations. In fact, foundations, real analysis, linear algebra. Okay, algebra. Yeah, very good articles.
So may I share the screen, sir? May I share the
sure.
page? Yes.
Thank you, Divya.
Yes.
I want to search, but somehow my browser is not working. That's
yes,
very
sir.
nice.
I'll share, sir.
That's what nice. Yeah, I can stop sharing. Yeah.
Yes, sir. So, yeah, live stream participants, thank you for your enthusiasm. So your feedback is very important. So give your feedback in the comment box. 8 participants, I think, viewing this. So give your comments in the comment box. If you want to, tomorrow is our valedictory session. If you want to join in the valedictory session, so send a mail foundations.mtts@gmail.com. I think Garima, please type foundations.mtts@gmail.com. So send a mail. Okay, wait for a minute. Okay, I'll share my screen. So, yeah, this is a textbook. Sir, please, sir.
Yeah, this is the textbook which I have just now written. Okay. Yes. And this book is written mainly for, see, that understanding purpose. Okay. If I want to understand on my own and understand to the core thoroughly. Okay. And see, if you are good at fundamentals, all of you know this. Okay. Your enthusiasm towards studying higher studies, there will not be any hurdles at all. You would have, in fact, you would understand things very fastly. So use this book to your maximum extent. And now Divya is showing the MTTS web page. Okay, there you could see expository article, and there is a link. Okay, and there will be a lot of articles which you can download and read. Yeah, that's it, Divya.
Video lectures are there, sir, in that?
Yeah. Thank you, Bala. There are also video lectures available in that website. Okay, video lectures right from in BSc level itself on linear algebra, real analysis, basic algebra. Okay, group theory and basic thing is that. So real analysis complete almost. Okay, a full course on real analysis is available there. So you can go through the video lectures also. Links are given there. Okay, try to use it to the maximum extent. Yeah, that's it.
Yes, thank you, sir. Thank you, live stream participants. Don't forget to give your feedback.